All right, hello. We're going to talk through the free response questions for the AP Review number 3, okay? Here is our very first question. The function f is defined by f of x is the square root of 25 minus x squared for negative 5 to 5 inclusive. A, find f prime of x. All right, f prime of x. That means we need the derivative of this. We know with roots and things, it's nice to rewrite them. So this really we can think of as 25 minus x squared quantity to the half power. And so my derivative then is going to be, it looks like a power rule. Yes, but I have a chain. I have an inside function here, right? So this is going to be a chain rule with a power rule that's sort of our outside component. So bring down the power, keep the inside, subtract 1 from the exponent, and then multiply by the derivative of the inside. Derivative of the inside will be negative 2x. So I would recommend leaving it like this. You do not need to simplify. If you are looking to simplify, the 2 and the 2 will cancel out. We'll end up with negative x over the square root of 25 minus x squared as our simplified derivative. If we want to, we can keep in mind that this is only going to work from negative 5 to 5 non-inclusive. X cannot be 5 or negative 5. But you did not need to write that out. Okay? So there we go. That is 2 points for getting the derivative right. I would stop here to avoid making a mistake. 2 points if you got that derivative or this one. Right? Okay. Let's take a look at part B. Part B says, write an equation for the tangent line. Write the equation for the line tangent to the graph of f at x equals negative 3. Tangent line. Well, for a tangent line, we need two things. We need a slope, and we need our point, right? For our slope, that means we need the derivative. Hey, we just got the derivative, right? We said the derivative was negative x over the square root of 25 minus x squared, right? That's what we said the derivative was. I want the slope of the derivative at x equals negative 3, so f prime of negative 3 is going to be 3, because it'll be negative 3, over the square root of 25 minus 9, because negative 3 squared is 9. That's going to give me 3 over the square root of 16. 3 over the square root of 16 is 4, right? So 3/4 looks like our slope, okay? Now what about our point? That means we need f of negative 3. f of negative 3, that's going to be the square root of 25 minus negative 3 squared. Square root of 25 minus quantity negative 3 squared. So that's going to be the square root of 25 minus 9. So that's going to be the square root of 16, which is going to give us 4. So what's the equation of our tangent line? Y minus, well, actually, I should say my point here then is negative 3, 4, right? That my tangent line passes through. So my line is y minus y1 equals m x minus x1, which in this case, I almost wrote x1. That's my point slope form. My x value in this case is negative 3. You can just leave it like this if you would like. I would encourage you to do that, or at least not go past this point right here. Okay? There we go. There is the equation of our tangent line. All right, you got 1 point for getting the correct derivative at negative 3 here. And you got 1 point for your final answer, either here or here. I guess you go all the way over. If you want to add 4 to the other side, you can also do that. Okay. And next, let's take a look at part C. All right, let G be the function defined by this piecewise function right here, which seems to have an interesting thing that will happen at whatever negative 3 is. Interesting. Is G continuous at x equals negative 3? Is G continuous at x equals negative 3? Use the definition of continuity to explain your answer. G is going to be continuous, okay? Well, if G is continuous. What does it mean if G is continuous? If G is continuous, we can say the limit as x approaches, well, if G is continuous, at x equals -3, then the limit as x approaches -3 of G of x exists. 2, G of -3 exists. And 3, the limit as x approaches -3 of G of x equals G of -3. Those three things need to be true, right? Limit has to exist, the point has to exist, and the limit as x approaches -3 of G of x has to equal G of -3. All those things have to be true. So let's just start at the top. Let's check them. If we want to check to see if the limit as x approaches -3 exists, what does that mean for us? That means the limit as x approaches -3 from the left of G of x has to equal the limit as x approaches -3 from the right of G of x. That's the definition of a limit existing, right? The limit, the left and the right-handed limits are going to be equal. So we can check that. The limit as x approaches -3 from the left. -3 from the left will be the top branch of this, which is f of x. So G follows f of x at the start here, and f of x is the square root of 25 minus x squared. Okay. That limit, the limit from the left side of -3, which follows f of x, has to equal then the limit as x approaches -3 from the right. As x approaches -3 from the right is going to follow x plus 7. Okay, so we just plug in -3 and try these out. That would be the square root of 25 minus 9. It's got to be equal to, plug in -3. -3 plus 7, that's going to give us 4, right? This is going to be the square root of 16, which is also going to give us 4. Okay, so what can we say then? The limit, so therefore, the limit as x approaches -3 of G of x exists. All right, we're being very thorough. That's the goal. We want to be really thorough, beyond reasonable, not even reasonable, beyond all doubt that this thing is continuous. So we did check that the limit exists. It does. We just showed that, right? Okay, now we got to check, okay, does G of -3 exist? G of -3 G of -3. G of -3. So what happens when x is -3? When x is -3, it follows this top branch. G of -3 will equal f of -3, which we found out was 4, right? Okay. G of -3 exists. Now, does the limit as x approaches -3 equal G of -3? It does. So I can say that, and the limit as x approaches -3 of G of x equals G of -3, which is 4. Therefore, G is continuous, I got cramped, at x equals -3. Okay. So I checked to make sure my limits exist by checking the left and right hand limit. Therefore, the limit existed because the left and the right hand both came to 4. G of -3, which from up here is f of -3, is 4. So my point exists, G of -3 exists, and that limit that I found, 4, equals the point 4. And so therefore G is continuous at x equals -3. How do the points break down? You got 1 point for considering the one-sided limit. So you got 1 point if you compared the one-sided limits here. And you got 1 point for your answer. G of x is continuous at x equals -3 with your explanation, which means you had to connect it back to your points up here, showing that the limit exists, point exists, and that they are equal. Okay? Your big key here is got to be able to show this step here, that the limit equals the point, which is 4, therefore G is continuous. 1 point for saying your answer with explanation, 1 point for showing your one-sided limits up here. All right, let's take a look at the next free response question that I gave you. I only gave you one part of this one. The other one I gave 3 out of the 4 parts. One part for this one. Let f be the function defined here. They get k square root of x minus natural log of x for x is greater than 0, where k is a positive constant. So k is some constant. All right. It says in part A, find the first derivative. Okay, so what is f of x? F of x is k. If I'm going to take a derivative, let me go ahead and rewrite this. This is k x to the half power minus the natural log of x. So what is the first derivative? First derivative is going to be, k is just some constant, right? So that is just going to stay. It's going to be a constant multiple. K times x to the half. So I'm going to bring down the half. I'll keep the k because it's just some constant. X to the negative half power. Okay. Minus the derivative of natural log of x is 1 over x. So there's my derivative. Nothing too fancy or too crazy, right? If you want to, you could have like rewritten this, but there's not really a point. We don't need to there. Especially because they ask us to find the second derivative. So what's our second derivative? Our second derivative of x, we continue then. So this, it's relatively easy to take the derivative of. You bring down the power again. Remember, k is a constant multiple, so it's just going to stay. Bring down the power again. That'll give me negative 1/4 k. Negative 1/4 k. X to the, I'll subtract 1 from that exponent again, give me negative 3/2. Minus, this is going to get interesting over here, right? 1 over x, I need the derivative of 1 over x, but what is 1 over x? 1 over x is x to the negative first power, right? So what's its derivative? Its derivative is negative 1, because I'm going to bring down the power, so that's going to make it positive here, because there's a minus already. Positive x to the, and I want to subtract 1 from the power there. All right. Because I had minus x to negative 1, so I'll bring down the negative 1. That'll make it positive. We're going to be adding. Subtract 1 from the exponent gives us negative 2. So there is my second derivative. I'm not going to simplify it. I don't really need to anymore. I am fine just taking the derivative and leaving it without making things look quote-unquote nice, right? There is then my second derivative. First up here, second derivative down here. All right, so how do the points break down for this? It's literally 1 point for your first derivative, 1 point for your second derivative, okay? Here we go. Cool. Please make sure you go ahead, look at the scoring guides, fill out the score report, and be sure to turn in the homework on time. Have a great rest of break, and I'll see you later.